For more than 1,000 years, there has been a problem with rockets. A big problem. Propellant. You need a lot of propellant to get to space. In fact, up to 96% of a spaceship's mass is propellant consisting of fuel and oxidizer. This is a result of one of the most difficult aspects of space travel, leaving the atmosphere. To fight gravity and leave Earth, you need to go 8 kilometers per second. Well, what if we turned our greatest obstacle, the atmosphere, into an asset? In July 2019, Team Fenris conducted a successful round of tests on the first ever air-breathing rocket engine, and the results will change space travel forever.
The fire went out the back, it pulled air in. That is an air-breathing rocket. That is a Fenris engine. Never before seen, first time here. Woo!
To fully grasp the effect an air-breathing system will have on space travel, we have to understand the tyranny of the rocket equation, which essentially states that in order to bring a spacecraft out of our atmosphere, you need a ton of fuel and oxidizer. But in order to transport this, you need even more fuel and oxidizer. Combined with the restraining forces of gravity, the amount of propellant needed to get to space is tremendous. This onboard propellant dependence has remained the biggest obstacle to reaching orbit since humankind's first attempt. In fact, many consider the giant leap for mankind not to be stepping on the moon, but attaining Earth orbit. The amount of oxygen needed on board to complete this chemical reaction that propels the craft out of our atmosphere is excessive. You'd think we would just use the oxygen in the atmosphere as free reaction mass until a vehicle enters space, right? For years, engineers have worked towards this and failed. Until now. Breathing air for a rocket motor means free oxidizer and free reaction mass. Fenris not only consumes the 21% oxygen in Earth's air as free oxidizer, but also uses the burned and unburned air as free reaction mass.
It's a hybrid rocket motor. You don't have to carry as much oxidizer as you would on a normal rocket motor. A normal rocket motor carries all of its own oxidizer and fuel. So it changes the rocket equation.
Fenris has 0 moving parts and suctions air as 19% of consumed propellant at a standstill.
Anything more than 5 or 10% is groundbreaking.
The Fenris rocket motor is made entirely of incremental, a cutting-edge aerospace alloy.
There's a lot more on the shelf that we haven't tapped into that's just barely a step away.
A Fenris rocket motor can be 3D printed, post-machined, inspected, acceptance tested, and flown in a matter of weeks. This new technology means less fuel per load, which means that we will be able to transport higher capacities into orbit at a much more efficient rate. Though it has been 50 years since humans last walked on the moon, we've never been more curious about space. In fact, the world hasn't seen an initiative like this since the 60s. SpaceX has been testing reusable spacecrafts, NASA is booting up their moon program again, and lots of people are trying to go to Mars. With proper resources, the Fenris will revolutionize space travel.
Get excited about space, because you've got a chance to go now. You really do. Like, you didn't have a chance before. This technology gives everyone a chance. It changes the entire equation, literally, on how to leave the planet. It's the end of the rocket age and the beginning of the Fenris age.